All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is concentration of solutions. You are going to need a calculator and a periodic table for this one, so if you don't have those handy, go ahead and pause the video and we'll get started. All right, we previously talked about molarity as a unit of concentration. We said that molarity was the number of moles of solute per liter of solvent. Now what we want to do is we want to take another look at a different type of unit of concentration, molality. Be careful with the spelling, they're close. Molarity is of course spelled with an R, molality with an L, and the symbol is a little bit different too. Molarity has a capital M as its symbol and molality a small m. So what's the difference? Well, we've already mentioned that molarity is moles of solute divided by liters of solvent. Molality, which by the way we'll use for colligative properties calculations involving freezing point and boiling point, is moles of solute per kilogram of solvent. So moles divided by kilograms. So let's do a couple of practice problems. Let's look at number one. Here's what it says. Number one says, calculate the molality of a solution in which 43.4 or 54.3 rather grams of potassium chloride has been dissolved in 500 milliliters of water, and we're given this water's density is 1 gram per milliliter. So the first thing we're going to do is we're going to add up the molar masses or the atomic weights of potassium and chlorine and add them together to give us the molecular weight for potassium chloride. It's 74.55 grams per mole. We're going to dissolve that into 500 milliliters of water. So we get 500 milliliters of water is equal to, remember, the density of water is 1 gram per milliliter, so that's going to be 500 grams of water, which is 0.500 kilograms of water. So now we've got the molecular weight of potassium chloride, and we've got the mass in kilograms of the solvent. So let's calculate. We're going to start with the 54.3 grams of potassium chloride that we've been given, and we're going to convert that into moles. So we're going to say 54.3 grams of potassium chloride times 1 mole of potassium chloride per 74.55 grams of potassium chloride. So that was the calculation that we did previously. And then we're going to divide by the number of kilograms of water, which we've already calculated again is 0.500 kilograms of water. When we do that calculation, we get this number to 3 significant digits, 1.46 molal potassium chloride. Remember, it is little m, molal, not big M, so make sure you've got the symbol right. All right, that's number one. Let's take a look at the second one. Number two says, calculate the molality of a solution in which 12.1 grams of carbon disulphide has been dissolved in 125 grams of carbon tetrachloride. All right, so carbon disulphide is the solute, carbon tetrachloride, the solvent. First thing we're going to do is we're going to add up carbon and 2 sulfurs to give us the molecular weight of the carbon disulphide. So that's going to add up to 76.15 grams per mole. Then we're going to convert the 125 grams of the solvent, which is carbon tetrachloride, into kilograms. So we get 0.125 kilograms of carbon tetrachloride. All right, we're set now. What we're going to do is we're going to take the 12.1 grams of carbon disulphide and convert that to moles. So we're going to do that by multiplying that by 1 mole of carbon disulphide per 76.15 grams of carbon disulphide. That's going to give us moles of carbon disulphide. We'll divide that by kilograms of the solvent, which is carbon tetrachloride, and we get 0.125 kilograms of carbon tetrachloride. When we do that calculation, 12.1 divided by 0.125 divided by 76.15, we get this value. We get 1.27 molal. Remember, that is molal, not molarity, not molar, but molal. 1.27 molal carbon disulphide, and that's our final answer. All right, number two, percent by mass and percent by volume. Let's take a look. Here's what it says. Number three says, in other cases, solution concentration may be more conveniently expressed by percent, either mass or volume. Percent mass is usually used if the solute is a solid, and percent volume if the solute is a liquid. So let's look at number three. We're going to do percent by mass first. Number three says, determine the mass of sodium chloride and mass of water required to make 2.50 kilograms of a 7% salt solution. So we want to make a 7% salt solution. How do we do that? Well, the first thing we're going to do is we're going to try to determine, or we're going to determine how much 7% of the total mass is. It's 2.5 kilograms or 2.50 kilograms. 7% you would get by multiplying that by 7 over 100. That's 7%. That's what percent means. Percent means divided by 100. So now when you do that calculation, you get 0.175, or if you want that in grams, you could say 175 grams of sodium chloride. So you're going to start by adding 175 grams of dry sodium chloride, just salt. Just put 175 grams of sodium chloride into the container, maybe a volumetric flask, for example. And then the rest is going to be water. Well, what's the rest? Well, remember the total mass is 2.50 kilograms. You're going to subtract this mass of the salt, and you're going to get 2.33 kilograms of water. So how do we make this solution, this 7% solution? Here's how we're going to do it. We're going to start out with 175 grams of sodium chloride, dry, placed into a volumetric flask. We're going to add to that 2.33 grams of water, and then we're going to stir, all right? That will give us the solution that we're looking for. That's number 3. Let's look at number 4. It says 150 milliliters of ethanol and 60 milliliters of water are mixed, okay? 150 milliliters and 60 milliliters of water are mixed. We want to calculate the percent by volume of the ethanol. So here's how we're going to do it. We're going to find the amount of ethanol. Okay, of course, the amount of ethanol is by volume 150 milliliters. Now remember, we're adding to that 60 milliliters of water. So the total amount of the total volume of ethanol and water, of course, is 150 plus 60. That's going to be 210. So if I want to know the percent by volume, I'll take the volume of the ethanol, which is 150 milliliters, and divide by the total amount. That's ethanol and water. We've already discussed that as being 210 milliliters times 100. 150 divided by 210 times 100 is 71.4%. This is a 71.4% ethanol solution, and that'll do it for the last one for me. And I think the last two we'll save for later. Parts per million and parts per billion are really not that important for right now. So we're going to save those for a little bit later in the year. So that'll do it for this worksheet, and I will see you on the next one. Thanks. Bye-bye.